All right, so yesterday we talked about a bunch of vocab for circles, and then we talked about the two theorems. The first, it says that a tangent line is perpendicular to the radius, and vice versa. And then the third one, which was that ice cream one, that says that if there are two tangents from the same point outside the circle, they're congruent. Yeah. So number one says just to name the best, give the name that best describes the figure. So line CD would be what? A secant. Good, a secant. If it was just segment CD, no, it couldn't even been segment CD. If it was like the C was here and it said segment CD, then it would have been a diameter. But because it passes through, it's a line, it's a secant, okay? And then AB, line AB would be? Tangent, good. So you would want, on a quiz, you'd want to be able to do it like that, or also go the other way. We did it like the example yesterday where you got the diagram and you had to give the name of things. All right, 2 says how many common tangent circles, how many common tangents do the circles have? Yeah.
1.
Good. Only this one would be able to go through both. And 3 is AB tangent to circle C and explain why. So how would I know it's tangent before you even get to the yes or no? Mars?
You do the Pythagorean theorem.
Good. So 16 squared plus 30 squared would have to be equal to 34 squared. I get 256 plus 900 and 1156. Are they equal? Yep. So it is yes. Because a squared plus b squared equals c squared, or if you want to give the exact like values, because 16 squared plus 30 squared equals 34 squared, making that a right triangle. Something like that. All right, so we're going to save this one for tomorrow because it leads into what we're about to do today. So on 10.1, what we left off with was the examples dealing with this theorem 10.2, which we called the ice cream cone one, right? So if you have two segments, they have to be segments, okay, because they have to stop. Otherwise, you can't measure them. They have to be tangent to the circle. If they come from an external point, they are congruent. The rest of these are all just examples, and it's going to be a blend of the theorem from yesterday, the Pythagorean, the one where it's right angle, and then the ones like the ice cream cone one.
Could you go back to slide?
All right, so example 5 says point B is a point of tangent C. Find the radius R of circle C. So this time, if it didn't even need to have this right angle mark, to be honest, because it tells you that it's the point of tangent C. As soon as you know it's the point of tangent C, you would know that's a right angle. So then if I want to find R, I have to set up my Pythagorean theorem, okay? The R from here would be squared plus the 24 squared, but that would equal this whole side, which is now R plus 16. So it would be R plus 16 squared. On the left side, I would obviously get R squared, and then 24 squared is 576. And then I cannot distribute that exponent. This does not go to both. What do I do on that side? Add what? Like R plus 16? Yeah. You can't, right? They're different terms. What would be R plus 16 squared? What would I do there? You can't square root. Okay, so let me actually address that one. You can't square root because on the left-hand side, it's a sum or a difference. If it was multiplication there, then I could square root. But because I have R squared plus something or R squared minus, you cannot.
Square it. Why don't you just square it?
Which would be what? What do you do when you square?
R squared.
Nope.
Is it R plus 16 or minus 16?
Nope.
You do R plus
There are
16,
two of the same things, right? You square it.
That's what I meant by
Oh,
square.
okay. And then you could use the shortcut, right? So the special product on that is square the first term, double the product here,
32.
and then square the last term,
Squared.
256. Or you FOIL it out. You do first, which would be R squared, outer 16R, inner 16R, last 256. Either way.
You still FOIL for like both ways, though, right?
Correct. Well, the shortcut for the first one, but you still do the same thing.
The shortcut is the steps you use to FOIL.
Sort of. Doubling the product is not the same as outer inner. That's just, yeah. Okay, then what?
Then you combine like this.
Okay, which terms?
256 and 576. And then
Then subtract r squared. 320 equals 32. Good.
You get
R equals 10. So just be careful on diagrams like this, okay? That where the R falls, it's telling you that's the radius, and it should make sense because these would be the same measurement. So then to get that whole side, you have to add the R and the 16. Questions on that one? All right, example 6. Point B is the point of tangency. Find the radius of circle C. You do this one. All right, so much like the last one, you're given the R for the radius and then the R and the 7 on the outside. This whole side would be R plus 7. So then R squared plus 14 squared would equal R plus 7 squared. 14 squared is 196. And then it would be R squared, double the product. So 7R times 2 would be positive 14R. And then square the 7, that's 49. Or expand and FOIL, either way. Subtract the 49. Subtract the R squared. And you get 147 equals 14R. Divide both sides by 14. And this time it doesn't go in evenly. So you could leave it, right, 140. You could leave it as 147 over 14, or you could actually divide that out. And it'd be, wait, yeah, 0.5. So on big ideas, I think it wants the decimal format. On a quiz, as long as this was simplified, you could have left it as that. Or you could put it into a mixed number. 10.5 is fine too. Questions on that one?
I have a question.
Yeah.
Let's say if 14 was like the number 16.
Yeah.
Can you just square root the whole thing?
No.
Why?
You mean from here?
Yes.
Because you can't square root a sum.
Wait. What?
If it's addition or subtraction like that, you can't square root them. If it was multiplication, if it said 25R squared equals something, now I can square root it. But you can't square root when it's a sum or difference.
Oh, okay.
All right, example 7 says points M and N are points of tangency. Find the value of X. So what is true about those two sides, Sophia? Good. They lead from the same external point, right? So X squared equals 9. Normally, when I square root, I have to do what in front of that plus and minus? I mean, in front of that square root. I sure did. I'd have to do plus and minus the square root of 9, which is 3. So you always want to check to see, does that make sense if I were to plug 3 back in? If that was just an X, I would keep the 3. I would get rid of the negative 3. But because that is a squared, when I put the negative back in, it goes away. So both of these are part of my answer. Again, if it would make your length negative, when you plugged it back in, you would not keep it. But because we're squaring that, you would keep both. All right. Points B and D are points of tangency. Find the values of X. Again, that ice cream cone shape, these are congruent. So 2X squared plus 2X would equal 7X plus 12. Then what? I'm going to move everything to one side. As soon as you see that squared and then non-squared X, right? I know I'm going to have to get everything to one side. So I'm going to move it so that the X squared term stays positive. So I get 2X squared minus 5X minus 12 equals 0. Then what?
Well, then you obviously solve.
How?
Right. You take so 2 times 12 is.
We factor it, right? We're going to factor it. We're going to see if we can factor it. Sometimes they're not going to be factorable. If it wasn't factorable, what would you do? Quadratic formula. That's why we just spent last week reviewing all this stuff.
And you would say not factorable.
Nope. That's not the right answer. All right, so I multiply first times last, I get negative 24. Are there factors of negative 24 that sum to negative 5?
3, 8.
Negative 8, positive 3. I wrote 5, positive 3. Rewrite the middle term with those two. And then factor by grouping. So from the first set of parentheses, I could take out a 2x, x minus 4. Second set of parentheses, you could take out a 3. And then x minus 4 comes out, group together 2x plus 3, and split and solve. So x equals 4, 2x equals negative 3, divide both sides by 2, and x equals negative 3 halves.
Do it.
Mars.
How do you, when you're factoring, how do you know which one to put first? Is it both?
It doesn't matter. If you would reverse it, you still would end up with the same thing. Like if I had 2x squared plus 3x minus 8x minus 12, and I group it, I take out an x. I take out a negative 4.
Oh,
The order switches, but the answer is still the same. So it doesn't matter. Good question. My children just, like, when they were doing this, and they learned a completely different way. I don't know if any, like, I'm
How
going
old are your children?
to, 7th and 8th grade. So
They
two,
already did this?
no, they're doing the factoring part of this. They're doing the factoring part of this. All right, so I don't know. I've never seen this before. But instead of doing first times last, they slide the first over by and multiply it times the last. Has anybody done this? X squared minus 5x minus 24 equals 0. Then they factor it. X minus 8x plus 3. But then they have to divide back by the 2.
That is pretty stupid.
X minus 4, and then x plus 3 halves, and you can't keep the fraction, so you multiply the x by the denominator. I'd never seen it before. I was like, hey, if it makes sense to you, that's fine. They kept forgetting to divide by the 2 at the end, so it's a little risky. But did anybody learn it that way in Algebra 1 Honors? No? Interesting.